Good afternoon, folks. How are you today? We are in week 10, so we are going to do this lab number 10, which is on 4-bar linkage. We solved this problem in the last lecture. What we are going to do is look at tying several elements together in this lab. Okay, so I hope you followed along what I was doing in lecture 29. So we had this 4-bar linkage, and we set up this spreadsheet template to solve this problem. So what we did was we had this transcendental equation in phi and theta. So theta was going to be the parameter that we were going to vary and find phi. We were going to solve this equation for theta from 0 to 360 degrees in step of 8 degrees. And we were going to use these three ratios of the four link lengths. So if you have not done so, I want you to reproduce the results that I did in the previous lecture. So let me bring up my spreadsheet of what we had done so far. So here is my spreadsheet. Remember what we did. We set up all these parameters. We started with a flag of false, initial values of 30 and 40 at theta is equal to 0. So you can see the chaining. And then what we did was we turned this to true. We got these errors. So we went to File, Options, Formulas. We set it up in manual mode, enabled iterative calculations. And then we did function F9, 2, 3, 4, 5. And in 5 iterations, we converged. And then we copied our final values. These were our phi values here, just values only, remember. And we switched on our automatic calculation. And disabled iterative. And of course, it gives us those error messages. Then what we did was we took these phi values and we had our visual basic functions. So we had forward derivative order 1, order 2, central derivative 1, derivative 2, and then backward derivative 1 and derivative 2. So we use that to create this table. Now in this one, what we did was we first found derivative of phi with respect to theta, second derivative, and then we multiplied by omega and omega square. So now our next task is, so I want you to have this table. Once you have this table, then we plotted theta versus phi and theta versus angular position, velocity, and acceleration. So we got this graph. So this is our slider crank. So let me shrink this now. So this is where we are. Okay, so I am going to hide all of these columns B through H. Because we don't need them anymore. Okay. So we have done this. We reproduced the results, plotted phi versus theta, set back to automatic mode, and now we have phi versus values. I just spoke. We created this table for H is equal to 8 degrees. and you reproduce the derivatives as in the previous lecture. The graph I just spoke about. Make sure that everything matches the results. If not, fix the problems. Now, our key question is how precise are our results? So let us do this by using Richardson extrapolation. So remember what we have. We already have results for 8 degrees H. So now we are going to take alternate rows and create for 16 degrees. Since we are using order H squared derivatives, we already have this. We are going to find this. And then because we have order H square and this ratio is 2, our weight factor would be 2 square or 4. So we are going to multiply this by 4, multiply this by -1, and get a new value, which is going to be order H to the power 4. And what we can do is these are the two last results. We can use that difference to say how many significant digits. So we can take a relative error or relative difference between the two and find the maximum value. Okay, so here is our assignment for Lab 10. So you have to do everything I've done for lecture 29, and then you're going to perform Richardson extrapolation using H is equal to 16 degrees, and we are going to determine how many significant digits do we have in our angular velocity and acceleration values. So I want you to add to your spreadsheet this particular titles. We are going to directly calculate for H is equal to 16 degrees, the velocity and acceleration. Then we are going to do Richardson extrapolation, just like I showed you on this paper. And we are going to find relative errors. And then we are going to calculate what was our maximum relative error so that we can say we have at least so many significant digits in our velocity and acceleration values. Okay, so here we go. So here are our formulas for H is equal to 16 degrees. I'm going to maximize my spreadsheet so I can see it. So we are going to multiply by omega directly and then take the derivative. So forward difference, first derivative, we are using 2 times H and we need 3 values. So this is going to be our first value. We skip second value, skip third value. Sorry, we are picking up wrong thing. I have to pick up this derivative, sorry. Phi, next, and next. We're taking derivative of phi. All right, here is our second derivative. Omega square times forward second derivative, 2 times H. And this needs 4 values. So we need 1, comma 2, comma 3, comma 4. Okay. Then next we want central difference. Omega times central difference, 2 times H, and it requires 3 values. So we'll take 1 before, 1 at, and one after. Omega square times central derivative 2 times h spacing. This also requires only 3 values. So previous, current, next. So we are skipping a row, so we'll take skip formula and copy it all the way down to row number 55. Great. Actually, if you want, we can even go one more. We can't. Sorry. Okay, so at the last value, we are going to use backward derivative. W times back derivative 1, 2 times h, comma. Now we need 3 values. So this is third, second, and first. All right. Omega square times back derivative 2. And this requires 4 values. So we start with 51, 2 times h, comma this, comma this, comma. Okay. So we have our values here. Next thing we are going to do, so we've got these formulas. Next thing we are going to do is extrapolation.